Quiz 2 key. Label each molecule as aromatic, antiaromatic, or neither. So this first one's aromatic because it has 1, 2, 3 pi bonds that are all conjugated. Now this second pi bond, right, for this alkyne triple bond, the p orbital there, right, if all the other p orbitals are like this, lined up, there's another set of p orbitals that's 150 or 90 degrees away. So this second pi bond is actually those red ones. So they're not part of the p orbital system, right? They're 90 degrees away. So that's aromatic, but there are 8 electrons in the p orbitals, but not all those 8 electrons are in doing resonance or part of the aromatic system. This one is neither, right? Because it has sp3 places, so it's an interrupted p orbital system. 2 electrons there. This one, 1, 2, 3, so that's 6 electrons total. 3 pairs, so that's aromatic in a ring. And this one could either said, I think if people said neither or anti-aromatic, I gave them the points for it. You could say 1, 2, 3, 4. So 8 electrons are in p orbitals, and you could call this aromatic or anti-aromatic. It's up to you. Draw 3 different resonance structures. Most folks did really well on this. Thing we got tripped up on was star the atoms where a nucleophile would react. So just basic resonance and just doing one arrow at a time. I only asked for 3 different ones, but I just kept giving them all. So really you could have put stars here, 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 or here. And actually even here too, some people did that, and that's totally fine. That's also a spot that's where a nucleophile would add. One thing that I would look out for is folks starred the oxygen, and that is not where a nucleophile would add. Just because the oxygen has a plus charge doesn't mean it's electrophilic. It's those atoms next to it after you do the resonance forms to kind of see where the plus charge could be at in the rings. That's where a nucleophile would react. All right, so number 3 was tough. Everybody did well using the first couple things. So label the molecule as acid or base. So this is acid, it's electron deficient. The base. Draw mechanism arrows, right? The nitrogen lone pairs grabs the H, right? And acid has polar bonds to hydrogen. Drew the 2 products out, sure enough. And then the question is, which side of the equilibrium is favored? Start materials or products, and explain. So the side that's actually favored is the products. And that's because, right, there's a couple ways you can think about it. This lone pair is closer to the nucleus. It's an sp2 hybrid orbital, which makes it closer to the positively charged nucleus, which makes it more stable. Or you could think of this lone pair as an sp3 hybrid orbital, which is farther from the nucleus, which makes it more reactive. So something that's more reactive, it's going to react. That makes the products more favorable. So that was the idea. It was basically taking hybridization state and basicity and see if you can understand how that would affect those things.